Hi everyone. Today's lesson is on what we refer to as rational functions, how to integrate rational functions. Now, what exactly is a rational function? It is a problem that can be written as a fraction. So all of the problems you are going to see in this lesson are written as fractions. Now, we've already covered some of these, so I'm going to make a little chart here, and I'm going to have what are called the different types of rational function problems that we've already done, and the method that we use to solve them. So I'm going to basically outline what we've done so far. So the first kind we came across were where the denominator is a single term. A single term. And basically that was an integral of like 5x minus 3 over x dx. That's a simple one. Okay. The bottom is a single term, the top had multiple terms. How did we work these? We split them into separate fractions. And this was in the lesson on logarithms, I believe. Okay. Now the second thing that we did was a scenario where the numerator, I'm spelling wrong again, numerator is the derivative of the denominator. And these were rather simple problems in that case, where we had an integral of 4 over 6x minus 2 dx. Okay, the bottom was multiple terms. The top, it either was the derivative of the bottom or you could make it that way. The method that we used was use substitution. Okay, today we're going to expand on this to include more types of problems. So the new material, we're going to start with a number 3, and it has the fact that the degree, which is considered the highest power, not sure if you're familiar with that term, of the numerator equals that of the denominator. And I'll point that out when I do the first problem. Now, this is a multi-step problem that we're going to do. It is a variation of number 1. So it's a problem where instead of having a single term on the bottom, we have multiple terms on the bottom. Now take a look for a minute at this problem right here. This problem is a scenario where the degree of the numerator and the denominator are the same. The degree is the highest power of the top, and the highest power of x on top is a 1. There's an invisible 1 right there. The highest power of x on the bottom is also 1. So this is a simple version of those kinds of problems. So now we're going to take a look at a more complicated version. So here are the steps to solve it. We're going to take the integral of 6x plus 4 over 3x plus 1 dx. All right. I'm going to put this in ABCs instead of 1, 2, 3s because I'm already using 1, 2, 3s. First thing you're going to do is you're going to make the leading coefficients match. Make the leading coefficients match. Now, what do I mean by leading coefficient? I mean the number in front of the highest power of x. Do you see that, like the problem I showed you a minute ago, the highest power of x in this problem is 1 for the top and the bottom. These two numbers here are the leading coefficients. I need to make them match. So, in order to turn a 3 into a 6, I would need to multiply the top and the bottom by 2. So I'm going to write this in red, not because it's a use substitution, but just to make it stand out. So I'm multiplying top and bottom by 2 over 2. Okay? The 2 on the bottom is going to multiply to the 3 to make it a 6. The 2 on the top is kind of extra baggage, so we're going to pull it out of the integral. So we're going to rewrite this problem as this 2 outside 2 integral 6x plus 4 over, now distribute the 2 on the bottom, 6x plus 2 dx. Now do you see that the top and bottom leading coefficients match? All right, second step, this is very simple. Put the denominator into brackets. So we're going to put a bracket around the denominator. That is now considered one whole single term like it was in example number 1 at the top of the screen. Okay? So the next step is to break the numerator so that it equals the denominator plus a constant. Okay, so let's take a look. Notice that the numerator is +4, the denominator is +2. I want to make a part of the numerator be exactly like the denominator. So what I'm going to do is I'm going to leave the 6x plus 2 on the bottom in a bracket. I'm going to take the 6x plus 4 and break it into 6x plus 2 plus another 2 dx. And now I'm going to put the numerator 6x plus 2 in a bracket as well. Okay? Now we are going to do the last step. We are going to split this into two fractions like we do in method number 1. So let me move this up. So now I'm going to write this as 2 integral 6x plus 2 over 6x plus 2 plus 2 over 6x plus 2 dx. That's what I mean by split it into two separate fractions. Now we can actually simplify this and make it work. Now that we've split it, the brackets really aren't necessary. But I'm going to go ahead and take them off on the next step. So we have 2 integral 6x plus 2 over itself is 1 plus 2 over 6x plus 2 dx. All right? Now remember we talked about if you have multiple terms in the problem, you can, in your head, break it into separate integrals. Now I'm going to go ahead and physically do it in this case because I need a u substitution for the back, but not for the front. So now I'm going to do a u substitution in the back. U is equal to the bottom. du is equal to the top. These are just like the problems from the logarithm section. Now actually, I misspoke just now. Du is not the top. We need to make du the top. Du is 6 dx. Now I have a 2 on top. So what I want to do is I want to multiply that 2 by 3 and then put a 1/3 outside of that integral only. That only applies to the first integral. Okay? So this is going to look a little weird. I'm going to go back and forth in colors because some stuff's going to change to x and other stuff is not. So 2 integral of 1 dx plus, now going to red, 1/3 integral. This right here is your du. It's 6 dx. The bottom of the fraction is u. Since there's nothing left for the top, we put a 1. Now I need to fix something because this 2 applies to everything. I need to put that whole thing in a bracket like so. Okay? So now the front of this is going to be 2. What is the integral of a 1? What has a derivative of a 1 dx? Well, that would be an x. Okay, now I need to integrate this other part. I have a 1/3. What is the antiderivative of 1 over u du? This is an ln, absolute value of u. Close my bracket. I gotta back up here. Close my bracket, plus c. And now to finish this up, we're going to change everything back to x's. I'm going to distribute the 2 at the same time. 2x plus 2 times 1/3 is 2/3 ln, absolute value of 6x plus 2 plus c. And that is your answer. Now this is a very complicated looking problem. In the back of the Griffith book, the answer looks slightly different, or actually this is right from his notes. He has, instead of 2/3 here, he has 4/6 because he distributed the 2 early on. I decided to leave the 2 out, which allowed my fraction to end up reduced. They're both correct. It doesn't matter which way you do the problem. All right. Now, the second, or actually number 4, is a lot easier because we know how to do U substitution. Number 4 is an expansion of number 2. It's the same method as number 2, it just has more different integrands. Now what is an integrand? It's what's inside the integral sign. And the steps to solve is not as involved as the other. It's actually much easier. This is just U substitution. So let's do a couple of these. The integral of 2x minus 3 over x squared minus 3x plus 1 dx. All right, let's look at the degrees. Notice how this one is different from number 3. The degree of the top, the highest power on an x on top is 1. The highest power on the x on the bottom is 2. When that happens, you know that you can't do method 3. I'm going to make a note here. Note that the degree of the numerator is less than the denominator. That's how you know you've got to go method 4. That is your key. Okay? And your other note, note 2, U will always be the denominator. 99% of the time. I'll say 99.9% of the time when you do these problems. Okay, I'm writing my U a little low this time just because of space here. U is the denominator. X squared minus 3x plus 1. What is du? Take the derivative of that. Don't look at what's on top. Take the derivative of what you see as u. That is 2x minus 3 dx. Do I have that? Actually, I have it exactly as I want it. It's right here. Okay? If your du contains an x and the x is not in your integral, something's wrong. You cannot introduce an x into an integral and put a 1 over x outside. You can only do that with constants. You can only do that with numbers. Fortunately, in this case, everything I need is right there. I don't need to put a number inside or outside. I'm ready to switch it to u's immediately. So now, I see what I circled is now my du. I have a fraction. The bottom is u. Nothing's left for the top, so the top is 1. These are just like the logarithm problems from before. So this will integrate to be ln, absolute value of u, plus c, which when we change it back to x's will be ln, absolute value of x squared minus 3x plus 1 plus c. All right, last example. This one is an integral with e's in it. The numerator is e to the 5x. The denominator is e to the 5x minus 3. Notice the minus 3 is not part of the exponent. It is down at the bottom, dx. Same steps as before. U needs to be the denominator. U is e to the 5x minus 3. And now you're going to have to go back to your formulas page possibly if you don't remember how to take the derivative of this. Now remember that derivatives of e's is copy-paste e to the 5x times the derivative of the exponent, which in this case is 5, and the derivative of the 3, remember, is 0, so that doesn't even come along. So this cleans up to be 5e to the 5x dx. Don't forget the dx. All right, look at what's on top. Is that exactly what I have? The answer is no, not quite. I need the 5, and I can introduce a 5, put a 5 up there, put a 1 over 5 outside. So now I have 1 over 5 integral. I'm going to circle all of that. That's my du. The bottom is u, top is 1. That's the way it should be. If you have any leftover numbers, throw them outside. The inside in these cases should always be 1 over u du. So this would be 1/5 ln absolute value of u plus c. change it back to x's, 1/5 ln, absolute value of e to the 5x minus 3. Remember, you're putting u in there, and plus c. And that's your answer. The assignment for this, the Griffith book, this is section 4.6, which is page 120. The Delta book, this is section 20.07, which is on page 358. Now, this is the last lesson that we're dealing with integrals for a while. We're going to be switching gears next week. We're going to be moving into conic sections, which is a not really a calculus related topic like derivatives and integrals, but is very important as you move on to university. All right. Good luck with this assignment, and let me know if you have any questions.